Hello, in this lecture we will find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that AE equals to ED. We also know that BE equals to 7 units and BF equals to 9 units. And we also know that angle ABE, this angle is equal to theta, and also angle EBF equals to theta. And we want to find out the area of this green shape. Okay, so first of all we will do a construction. We will extend line segment BE and line segment CD until they intersect with each other. We will define the intersection point between CD and BE as point P. This point is point P, the point where the two line segments meet, intersect with each other. And we also know that all the angles inside the rectangle are right angles, therefore ABCD is a rectangle, so therefore this angle equals to 90 degrees. This angle also equals to 90 degrees. As this angle is a right angle, it equals to 90 degrees. So we will define angle PDE as x, and we will find out the value of angle x. So first of all I will present to you a new rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll write it down. The sum of the angles on one side of a straight line is equal to 180 degrees. So I will repeat on rule number 1 again. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So here CD is one side of a straight line. CD is one side of rectangle ABCD, therefore it is absolutely a straight line. And we actually, the construction that we made was to extend the straight line CD by a straight line, and in this way we created the line segment CP. So because of the fact that we extended the straight line CD by a straight line, so CP will be still a straight line. So you can write down that CP is a straight line. When we extended the straight line CD by a straight line, CP will be still a straight line. And if we focus on this side of the straight line CP at point D, the sum of the angles must be equal to 180 degrees according to rule number 1, that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, on this side of the straight line CP at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D at this side? We have angle X plus this angle that is a right angle, that is to say it equals to 90 degrees. The sum of those two angles must be equal to 180 degrees according to rule number 1. I'll repeat again. The sum of the angles on one side of point D on the straight line CP must be equal to 180 degrees, that is to say x plus 90 degrees must be equal to 180 degrees according to rule number 1. So here we will subtract 90 degrees from this equation and we will get that x equals to x equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle x is a right angle, that is to say it equals to 90 degrees. So we can substitute angle x by a right angle. So angle PDE, this angle is a right angle. It equals to 90 degrees. And we also know that the opposite sides of a rectangle are parallel to each other. That is to say AB is parallel to CD. So we can write down that AB is parallel to CD. And as I have already, so CD is a straight line and the straight line AB is parallel to the straight line CD. And the construction that we did is we extended the straight line CD by a straight line. So CP is also a straight line. And because of the fact that AB is parallel to the straight line CD, AB will be also parallel to the same straight line CP. Okay? Because CP is the extension of the straight line CD by a straight line. So because of the fact that AB is parallel to CD, then AB will be also parallel to CP because it is the same straight line. Okay, so AB is parallel to CP. And we have rule number 2. So we know that AB is parallel to CP. According to rule number 2, alternating angles between parallel lines are equal to each other. So I'll repeat rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. And actually, those two angles are defined as alternating angles, and they are located between the parallel lines AB and CP. I showed you that AB is parallel to CP, so the alternating angles, those two alternating angles that are located between the parallel lines AB and CP are equal to each other according to rule number 2. So actually angle ABE equals to angle DPE according to rule number 2. I'll repeat again. Angle ABE equals to angle DPE according to rule number 2, because those two angles are defined as alternating angles and are located between the parallel lines AB and CP, therefore they are equal to each other according to rule number 2. But it is given us in the question that angle ABE equals to theta. Okay, angle ABE equals to theta according to what is given us in the question. So from this equality we will conclude that angle DPE also equals to theta. Angle DPE equals to theta. So we can write here at angle DPE, this angle equals to theta. On the next step, we will prove that those two triangles can go into each other. So the triangle ABE, this green triangle, right triangle, can go into triangle DPE. Okay? So we'll focus on the right triangle, triangle ABE, the green right triangle, triangle ABE. we focus on the right triangle, triangle ABE. And the right triangle, triangle PED, this right triangle. And we will prove that those two right triangles can go into each other. First of all, it is given us the question that AE equals to ED. AE equals to ED. It is given us the question that AE equals to ED. We also know that those two angles, they are right angles, therefore they are equal to each other. That is to say, this angle is angle BAE. Is equal to angle, this angle, angle PDE. And they are both equal to 90 degrees. I repeat again, AE equals to ED because it is given us the question. Angle BAE equals to angle PDE equals to 90 degrees. And those two angles are defined as vertex angles. And we have the rule that vertex angles are equal to each other, so those two angles are equal to each other. That is to say, angle BEA of the green triangle is equal to angle PED, this angle. According to the rule that vertex angles are equal to each other. I'll repeat again. Angle BEA equals to angle PED. According to the rule that vertex angles are equal to each other. So we actually proved that all three angles of the green triangle BABE can go into all the three angles of triangle PED. And we also have AE is equal to ED according to what is given us in the question. Actually, we also have those two angles. They are also equal to each other. They are equal to theta according to rule number 2. So I write it down. Angle ABE of the green triangle is equal to angle EPD, this angle, and both those two angles are equal to theta. So angle ABE equals to angle EPD, and they are both equal to theta according to rule number 2. So we actually prove that all three angles of the green triangle congruent to all three angles of triangle PED, and also we proved that AE equals to ED. Therefore, those two triangles, those two right triangles congruent to each other according to side angle rules. So I write it down. So actually, we proved that the right green triangle ABE congruent, this is the sign of congruent, to the right triangle PED, according to side angle rule. Okay, I'll repeat again. We prove that triangle ABE, the green right triangle, is congruent to triangle PED according to side angle rule. So what is side angle rule? Side angle rule states that if two angles and the side that included between those two angles congruent correspondingly to two angles and the side that included between those two angles in another triangle then the two triangles congruent to each other according to angle, side, angle, rule. So I'll read the rule again. According to angle, side, angle rule, if two angles and the side that included between those two angles I should add in one triangle. So I will read the rule again. If two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included between those two angles in another triangle, then the two triangles congruent to each other according to angle, side, angle rule. Okay, and actually we proved that those two angles and side AE in the green triangle congruent to those two angles inside ED in triangle PED. Therefore, we proved that those two right triangles congruent to each other according to angle, side, angle rule. And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. BE equals to EP. BE equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, the two corresponding sides, that is to say BE and EP, will be equal to each other. And we know that BE equals to 7 units. It is given us in the question, so we can write down that BE equals to 7. BE equals to 7 units. It is given us in the question, so from this equality, we will conclude that EP also equals to 7 units. EP equals to 7 units. So right here that EP equals to 7 units. And we will define the area of quadrilateral BEDF SY. Again, the area of quadrilateral BEDF is defined as Y. Okay, the area of this quadrilateral BEDF is Y, according to our definition, and we will define the area of the green right triangle as X. The area of the green right triangle BAE is defined as X. So we have to find out the area of the green shape, and the area of the green shape equals to X plus Y. Okay. The area of the green shape this sign is a sign for the area of the green shape. Those two brackets are the sign for the area, so it means the area of the green shape equals to x plus y. According to our definition, it equals to x plus y. And we have to find out the value of x plus y. And because of the fact that those two triangles can go into each other, we proved that triangle BAE is congruent to triangle PDE according to angle side angle rule. Therefore, they also have the same areas. So if the area of triangle ABE is x, then the area of triangle EPD will be also equal to x. Very simple. And the area of triangle BPF, the area of triangle BPF also equals to x plus y, equals to x plus y. I'll repeat again. The area of triangle BPF equals to x plus y exactly as the green area that also equals to x plus y. So we can simply find out the area of triangle BPF, and in this way we will also actually find out the area of the green shape, because they have the same areas, that is to say x plus y. Okay, so we will find out the area of triangle BPF, that is the area of the green shape. Okay. Triangle BPF is an isosceles triangle because it has two angles that are equal to each other. Both those two angles are equal to theta. Therefore, triangle BPF is an isosceles triangle. I write it down. Triangle BPF is an isosceles triangle. Okay, triangle BPF is an isosceles triangle because of the fact that it has two angles that are equal to each other. That is to say, both angles of triangle BPF equal to theta. Those two angles are both equal to theta. Therefore, it is isosceles triangle. It's an isosceles triangle. And we have rule number 3. You should also remember that at point E, the base BP of the isosceles triangle BPE at point E, it divides the base BP into two equal parts. This part of the base BP equals to 7 units, and this part EP also equals to 7 units. So point E is the point where the base BP is bisected. Okay? So I will present to you rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. I will repeat again on rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have triangle ABC that is an isosceles triangle, so this is triangle ABC, and triangle ABC equals has two equal angles, theta and theta, therefore it is defined as an isosceles triangle, and the base of the isosceles triangle, triangle ABC, is BC. If from point A we draw median to the base BC, so actually the median divides the base BC into two equal parts. If we define the touching point between the median and the base BC as point O, then according to the definition of a median, it bisects the base BC, or it divides it to two equal parts. So if BO equals to X, then OC will be also equal to X. This is the definition of a median. It bisects the side that it eats. Okay, the median AO eats the base BC at point O, therefore it bisects it into two equal parts. VO equals to OC. Okay, and according to rule number 3, the median to the base AO is also perpendicular to the base BC. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So according to rule number 3, if we have an isosceles triangle ABC, then the median AO to the base BC is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So we can implement rule number 3 in our drawing, because here we have the isosceles triangle BPF. It is isosceles triangle because it has two equal angles, they are both equal to theta, and the base is BP. So the median from point F to the base BP, that is to say FE, the median FE to the base BP in the isosceles triangle BPF, it divides the base BP into two equal parts. BE equals to 7 units and EP also equals to 7 units. So it divides it to two equal parts. And according to rule number 3, the median to the base FE is also perpendicular to the base BP. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? That is the implementation of rule number 3 in the isosceles triangle BFP. The median FE to the base BP is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So, if this angle is a right angle, then the green triangle BEF is a right triangle, and we can implement the Pythagoras theorem in order to find out the length of the median EF. So we will do it now. So we will focus on the green right triangle BEF. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars in the right triangle BEF, and in any other right triangle, the hypotenuse in the green right triangle BEF is BF, therefore the square of the hypotenuse is BF square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to BE square plus EF square. I will repeat again. In the green right triangle BEF, according to the Pythagoras theorem that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, BF squared equals to BE squared plus EF squared. Okay? But it is given us in the question that BF equals to 9 units. BF equals to 9 units. If BF is 9, then BF squared is 9 squared. 9 squared is 81 equals to BE squared. It is given us in the question that BE equals to 7 units, therefore BE squared is 7 squared. 7 squared is 49. Plus EF squared. EF is the missing variable, so it is EF squared. So in conclusion, we found out that 81 equals to 49 plus EF squared. Here we will subtract from this equation number 1, 49, and we will get that 81 minus 49 is 32. So EF squared equals to 32. EF squared equals to 32. We will take a root out of this equation number 1, and we will get that EF equals to the square root of 32. Okay, but we know that 32 is 16 times 2. So we substitute 32 by 16 times 2, and the square root of 16 is 4, so I write it down. We'll get that it equals to 4 times square root of 2. So in conclusion, we found out that EF, the median EF, equals to 4 times square root of 2 units. So we can write here that EF equals to 4 times square root of 2 units. So actually EF is the height to the base BP, so it is very easy to, we can easily find out the area of triangle BPF. The area of any triangle, and especially triangle BPF, is equal to the base times the height to the base over 2. The area of the isosceles triangle BPF, and the area of any triangle is equal to the base of the triangle times the height to the base over 2. So here the base is BP, the base of the isosceles triangle BPF is BP, the height to the base is EF, because the height EF creates 90 degrees with the base BP over 2. So we found out that the area of the isosceles triangle BPF equals to the base that is actually BF times the height to the base that is EF over 2. Actually, the base is BP. The base is BP. The base is BP. The base of the isosceles triangle BPF is BP, so the base is BP times the height that is EF over 2. I write it again. BP is the base times the height that is EF over 2. Again, the area of the isosceles triangle BPF equals to the base that is BP times the height to the base that is EF over 2. And so the base BP equals to 7 plus 7, that is 14, times the height to the base, that is 4 times 2, 4 times square root of 2 over 2. So we found out that the area of the isosceles triangle BPF, that is also the area of the green shape, equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so I'll write it down. 7 times 4 times square root of 2 over 2. That is the area of the isosceles triangle and also the area of the green shape. 7 times 4 times square root of 2 over 2. 7 times 4 is 28. So in conclusion, we found out that the area of the green shape equals to, it is actually 14 over 2 is 7, so the area of the green shape equals to 7 times 4 times square root of 2. 7 times 4 is 28, so in conclusion we found out that the area of the green shape equals to 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units. That is the area of the green shape. I'll repeat again, the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so we finished with the first method. In the next step, I will present to you the second method. In the second method, the second method to find out the area of the green shape. Here we know that AB is parallel to CD, according to the rule that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to CD in rectangle ABCD, then AB will be also parallel to FC. AB will be also parallel to FC. So I write it down. AB is parallel to FC. And because of the fact that AB is parallel to FC, according to rule number 2, those two angles that are located between the parallel lines AB and FC will be equal to each other. The rule that I stated, that I mentioned in method 1, alternating angles between parallel lines are equal to each other. Those two angles are defined as alternating angles, and they are located between the parallel lines AB and CF and FC, therefore they are equal to each other. So this angle is 2 theta, and it equals to this angle, therefore it will be also, this angle will be also equal to 2 theta. Okay? I repeat again. According to rule number 2, that alternating angles that are located between parallel lines are equal to each other. Those two angles are alternating angles, and they are located between the parallel lines AB and FC, therefore they are equal to each other. So if this angle is 2 theta, then this angle will be also equal to 2 theta, very simple. And we also know that all the angles inside the rectangle are right angles, therefore this angle will be equal to 90 degrees. This angle will be also equal to 90 degrees, and this angle, it is also a right angle, it equals to 90 degrees. So in the right green triangle, triangle ABE, actually I will draw it again. We will focus on the right green triangle, triangle ABE, this green right triangle. We will define AE as X. So if AE equals to X, then, and we know that AE equals to ED according to what is given in the question, then ED will be also equal to X. So here AE equals to X according to our definition, and it is given us in the question that BE equals to 7 units. So actually, in the right triangle, triangle ABE, sinus theta equals to X over 7. X over 7. This is the question 1. in the lower right triangle, triangle BFC, sinus 2 theta, sinus 2 theta equals to BC over 9. It equals to BC over 9. But we know that the opposite sides of a rectangle are equal to each other, and we have already found out that AD equals to x plus x, that is to say AD equals to 2x, and the opposite side AD equals to BC. So if AD equals to 2x, then BC will be also equal to 2x. So sinus 2 theta equals to BC over 9, but BC equals to 2x. Therefore, sinus 2 theta equals to BC, that is 2x over 9. Okay? But we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosinus theta. So according to this trigonometric identity, we can substitute sinus theta by 2 sinus theta cosine theta. So we'll do it. Sinus 2 theta equals to 2 sine theta cosine theta. And it equals to 2x over 9, according to equation number 2. Okay? So, according to equation number 2, 2 sinus theta cosine theta equals to 2x over 9. But we have already found out that according to equation number 1, sine theta equals to x over 7. So we can substitute sine theta in this equation, equation number 2, by x over 7. We will do it now, and we will get that 2 times sine theta is x over 7 according to equation 1, times cosine theta according to equation number 2 equals to 2x over 9. Here we have 2x on both sides of equation number 2, so 2x will get cancelled. And what is left from equation number 2 after we cancel 2x? What is left? It is actually on this side of equation number 2, we have cosine theta over 7 equals to 1 over 9. So here we will multiply this equation number 2 by 7, and we will get that cosine theta equals to 7 over 9. Okay, cosine theta equals to 7 over 9. So actually we found out that according to equation number 2, cosine theta equals to 7 over 9, and according to equation number 1, sine theta equals to x over 7. So what is cosine theta equals to 7 over 9? If we draw this function of cosine theta that equals to 7 over 9, we will get that we actually have here a right triangle with the hypotenuse that equals to 9 units. This angle is theta, and the angle that is near angle theta is equal to 7 units. This is the function that this drawing describes the function that cosine theta equals to 7 over 9. And if we want to find out the value of the side that is in front of angle theta, we'll define it as x, and it will be equal to, according to the Pythagoras theorem, we know that 7 square plus s square equals to 9 square. The square of the hypotenuse equals to the sum of the square of the perpendiculars. We subtract 7 square from this equation, and we get that s square equals to 9 square minus 7 square. Okay, s square equals to 9 square, that is 81, minus 7 square, that is 49. 81 minus 49 is 32. So we found out that s square equals to 32. We will take a root out of this equation, and we will get that s equals to the square root of 32, but 32 is 16 times 2, so we write it down, 16 times 2. The square root of 16 is 4, so in conclusion we've got that s equals to 4 times square root of 2. S equals to 4 times square root of 2. Okay, so actually here, if we calculate now, if we focus on this drawing and we will calculate the value of sine theta, we will get that sine theta equals to s, that is 4 times square root 2, over 9. And we have already found out that cosine theta equals to 7 over 9. Okay, I repeat again, we found out that sine theta equals to 4 times square root of 2 over 9, and cosine theta equals to 7 over 9. Now we have this equation number 2 states that cosine theta equals to 7 over 9 and sine theta equals to x over 7. Okay, sine theta equals to x over 7. So here, so you can see in the right triangle, triangle ABE, the green right triangle, triangle ABE, sine theta equals to x over 7. Sine theta equals to x over 7. But we have already found out the value of sine theta. It equals to 4 times square root of 2 over 9, and it equals to x over 7. we will multiply this equation by 7 and we will get that x equals to 7 times 4 is 28, square root of 2 over 9. So we actually found out the value of x. Here x equals to 28 times square root of 2 over 9. Here also x equals to 28 times square root of 2 over 9. And here, if x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. And here also AD will be also equal to 56 times square root of 2 over 9. And we have already found out, okay, as here we will focus on the green right triangle ABE, on the green right triangle ABE, cosine theta, this green right triangle, cosine theta equals to AB over BF, that is 7, AB over 7. Okay, cosine theta equals to AB over 7. But we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9 in this equation. And we get that 7 over 9 equals to AB over 7. We will multiply this equation by 7 and we will get that AB equals to 7 times 7 is 49 over 9. So we found out that AB equals to 49 over 9. So we can write here that AB equals to 49 over 9. And because of the fact that the opposite sides of a rectangle are equal to each other, it means that DC also equals to AB equals to 49 over 9. DC also equals to 49 over 9. So here DC equals to 49 over 9 units. And in the next step we will focus on this right triangle BFC. On the right triangle BFC, according to, we know that sine 2 theta equals to BC over BF. Okay? In the right triangle BFC, sine actually on the right triangle BFC, cosine 2 theta equals to FC over BF is 9. Okay, so I'll repeat again. In the right triangle VFC, cosine 2 theta equals to FC over 9. We will multiply this equation by 9 and we will get that cosine 9 times cosine 2 theta equals to FC. We have the trigonometric identity that cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine theta in this equation number 2, by 2 times cosine square theta minus 1 from this trigonometric identity. So we'll do it now and we'll get that 9 times cosine 2 theta is 2 cosine square theta minus 1, and it equals to FC. Okay, but we have already found out that cosine theta equals to 7 over 9. We know that cosine theta equals to 7 over 9, so we can substitute cosine theta in the equation number 2 by 7 over 9. We'll do it now and we'll get that nine times 2 cosine theta is 7 over 9, and cosine square theta is 7 over 9 square minus 1 equals to FC. So here, actually 7 over 9 square is 49 over 81. So you write it down. We will substitute minus 1 by minus 81 over 81, that equals to minus 1. So we found out that FC equals to 9 times 2, 49 minus 81 over 81. Here, 2 times 49 is 98, so I'll write it down. So we found out that FC equals to this expression. Here, 98 minus 81 is 17. 17, and we will divide the numerator and the denominator by 9. 9 over 9 is 1, and 81 over 9 is 9. So in conclusion, we found out that FC equals to 17 over 9 units. FC equals to 17 over 9 units, so we can write here that FC equals to 17 over 9 units. What is the value of DF? DF equals to DC minus FC. DC minus FC equals to DF. I'll repeat again. DF equals to DC minus FC. So actually DF equals to DC. We know that DC equals to 49 over 9. Minus FC. We already found out that FC equals to, actually it is 17 over 9. FC equals to 17 over 9. So in conclusion, we found out that DF equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32, so I'll write it down. In conclusion, we found out that DF equals to 32 over 9 units, so I'll write it down. 32 over 9 units. So actually we found out all the sides of the trapeze ABFD, so we can calculate the area of the trapeze that is actually also the area of the green shape. Okay, so the area of this green shape is the area of trapeze ABDF. The area of trapeze ABDF, we know that the area of any trapeze, and especially trapeze ABDF, equals to the sum of its sides, that is to say AB plus DF, times the height is AD, over 2. So the area of the green trapeze, that is also the area of the green shape, ABDF, equals to AB plus DF times AD over 2. Okay? So the area of trapeze ABDF equals to AB is 49 over 9 plus DF is 32 over 9 times AD is 56 times square root of 2 over 9 over 2. Okay, so we found out that the area of trapeze ABDF equals to this expression. Here 49 plus 32 is 81. So here we have 81 over 9 times 9. That is actually 81 over 81. This is 1. So the area of trapeze ABDF, that is also the area of the green shape, equals to 81 over 9 times 9, that is also 81, times 56 times square root of 2 over 2. Okay, so the area of the green shape or trapeze ABDF equals to 89 times 9 is 81. 81 over 81 is 1, so this expression will get cancelled. And we actually found out that the area of the green shape equals to 56 over 2 is 28 square times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I repeat again, the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. In the next step, I will present to you the third method. That is to say, we will find out the area of this green shape according to the third method. So here, in the first method, we will do a construction from point E. We will draw perpendicular to BF. So this angle is a right angle, that is to say it equals to 90 degrees, and this angle, it is also a right angle. And we also know that all the angles inside the rectangle are right angles, so all the angles inside rectangle ABCD are right angles, that is to say this angle is equal to 90 degrees in its size. This angle also equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will prove that those two right triangles can go into each other. So we will focus on the right triangle, triangle ABE, this right triangle, and the right triangle, triangle BE, will define the touching point between the perpendicular from point E to BF as point M. So we will prove that the right triangle BAE is congruent to the right triangle BEM. This right triangle, triangle BEM. First of all, those two angles, they are equal to each other, they are both equal to theta, so I will write it down. Angle ABE in triangle ABE is equal to angle EBM in triangle EBM, and they are both equal to theta. It is given us in the question. Okay, angle EBM, ABE equals to angle EBM, and they are both equal to theta. It is given us in the question. We also know that those two angles are equal to each other, they are both right angles. So I write it down, angle BAE is equal to angle BME and it equals to 90 degrees. I'll repeat again, angle BAE equals to angle BME, both angles, the right angles, are equal to 90 degrees. And those two angles, they are equal to each other according to third angle theorem. So angle AEB, this angle, is equal to angle BEM, this angle, according to third angle theorem. So what is third angle theorem? Third angle theorem is that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. And here we have those two angles in the green right triangle, triangle ABE, congruent to those two angles in triangle EBM. Therefore, the third pair of angles must also congruent. Those angles must be equal to each other according to third angle theorem. So angle AEB equals to angle BEM according to third angle theorem. And we also have side BE is a common side, it belongs to both triangles, so BE equals to BE, BE equals to BE. It is a common side that belongs to both triangles. I'll repeat again, BE equals to BE. It is a common side that belongs to both triangles. So we actually proved the triangle ABE is congruent to triangle BEM according to angle side angle theorem. We proved the triangle ABE congruent to triangle BEM according to angle side angle rule. Okay, and from the fact that those two triangles can go into each other, we will conclude that AB equals to BM, AB equals to BM, AB equals to BM, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides AB and BM will be equal to each other. And if we define AB as y, then BM will be also equal to y, because they are equal to each other. So if BF it equals to 9 units, if BF equals to 9 units, then BF minus BM equals to MF. So BF that is 9 units minus BM that is y, it is actually 9 minus y. So actually MF equals to 9 minus y. And also, if we define AE as x, then ED will be also equals to x because of the fact that AE equals to ED. So both are equal to x, and because of the fact that those two triangles can go into each other, AE equals to EM. AE equals to EM. AE also equals to EM, according to the rule that corresponding sides in congruent triangles are equal to each other. But we know that AE equals to x, so EM also will be equal to x. Okay, here it equals to x, and okay, and it equals to y. Okay, in the next step, we will join together points E and F by a straight line. And we will prove that those two right triangles can go into each other. That is to say, we will prove that triangle EDF congruent to triangle EMF. First of all, we know that EM equals to ED equals to X. EM equals to ED equals to X. Okay, EM equals to ED equals to X. And EF equals to EF, it is a common side that belongs to both triangles. EF equals to EF, it is a common side that belongs to both triangles. And those two angles, they are right angles, therefore they are equal to each other, so angle EMF, angle EMF equals to angle EDF. And they are both equal to 90 degrees. Again, angle EMF equals to angle EDF, they are both equal to 90 degrees. So, by proving those three things, we actually proved that those two triangles, those two right triangles can go into each other according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and a perpendicular in two right triangles congruent, then the triangles congruent to each other. I'll repeat again on rule number 5, according to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. And we actually proved here that the hypotenuse EF and the perpendicular EM in the right triangle EFM congruent to the hypotenuse EF and the perpendicular ED in the right triangle EDF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. So we can write down that we proved the triangle EDF congruent to triangle EMF according to rule number 5. I'll repeat again. We proved that the right triangle EDF congruent to the right triangle EMF according to rule number 5. And from the fact that those two triangles congruent to each other, we will conclude that MF equals to DF. MF equals to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides MF and DF will be equal to each other. And if MF equals to 9 minus y, then DF will be also equal to 9 minus y because of the fact that they are equal to each other. And we know that the opposite sides of a rectangle are equal to each other, so AB equals to DC. But AB equals to y according to our definition, so DC will be also equal to y. Okay? So DC equals to y. And we know that DC minus DF equals to FC. DC minus DF equals to FC. So actually FC equals to DC is y minus DF. DF is 9 minus y. So we found out that FC equals to y minus 9 minus y. We open the brackets here and we get that FC equals to y minus 9 minus y is plus y. So it equals to 2y minus 9. So FC equals to 2y minus 9. FC equals to 2y minus 9. And we know that the opposite sides of a rectangle are equal to each other. AB equals to x plus x, that is to say it equals to 2x, then BC also will be equal to 2x because AB equals to BC. So it is 2x. So in the next step we will focus on the right triangle ABE. On this right triangle ABE, According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is BE square. BE square is 7 square. 7 square is 49. 49 equals to AE square is x square plus AB square is y square. So according to equation number 1, x square plus y square equals to 49, and we'll focus on the right triangle BFC. Here, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the square of the perpendiculars. The hypotenuse is BF is 9, so the square of the hypotenuse is 9 square. 9 square is 81, equals to FC square. That is to say, it equals to 2y minus 9 square plus BC square. 2x square is 4x square. So in conclusion, we found out that 81 equals to 2y minus 9 square plus 4x square. We will open the brackets of this equation, equation number 2, and we will get that 81 equals to 4y square plus 81 minus 36y plus 4x square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled. And here is 0 equals to, here we take 4 as a common factor, for 4y square plus 4x square, it will be 4x square plus y square minus 36y. So here we will add 36y to this equation, equation number 2, and we will get that here we know that x square plus y square is 49, so we'll substitute x square plus y square by 49 in this equation, equation number 2, and we will get that 4 times x square plus y square is 49. So we got that 36 equals to 4 times 49, 36y equals to 4 times 49. We will divide this equation by 4, and we will get that 9y equals to 49. We will divide this equation by 9, and we will get that, according to equation number 2, y equals to 49 over 9. Y equals to 49 over 9. So here we will put the value of y from equation number 2 in y square from equation number 1, and we will get that 49 equals to x squared, and y is 49 over 9, 49 over 9 squared. So we will subtract 49 over 9 squared from this equation, equation number 1, and we will get that x squared equals to 49 minus 49 over 9 squared. 49 is 7 squared, so I write it down. So x squared equals to 7 squared minus 49 over 9 squared. So here we'll use the algebraic identity that a squared minus b squared equals to a plus b, a minus b. Here b squared is 0, a equals to 7, and b equals to 49 over 9. So So in conclusion, we will get that x squared equals to 7 plus 49 over 9 times 7 minus 49 over 9. We will multiply 7 by 9 and then we will divide it by 9 in order to have a common factor with this expression, and we will get that x squared equals to 63 plus 49 over 49 times 63 minus 49 over 9. So x squared equals to 63 plus 49 is 112 over 9, and 63 minus 49 is 14 over 9. We know that 112 is 14 times 8, so I write it down. X squared equals to 8 times 14 times 14 over 9 times 9. So here 8 is 2 times 2 times 2, so I write it down. X squared equals to 2 times 2 times 2 times 14 over 9 times 9 times 9. Here we take a root out of this equation, equation number 1, and we'll get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So here the square root of 2 times 2 is 2, and the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion, we will get that x equals to 2 times 14 over 9 times square root of 2 units. And we have already found out that y equals to 49 over 9. So we found the values of x and y. And in the next step we can find easily the area of the green shape, that is actually the area of trapeze ABDF. The area of trapeze ABDF will be equal to AB plus DF times AD, the height AD over 2. I repeat again, the area of trapeze ABDF, that is the area of the green shape, equals to AB plus DF times AD over 2. So the area of trapeze ABDF, that is the area of the green shape, will be equal to AB is y plus DF is 9 minus y times AD is 2x over 2. So the area of the green shape ABDF, here y minus y is 0 and 2 over 2 is 1. So we found out that the area of the green shape AB, or the area of trapeze ABDF, equals to 9x. That is what is left for me after we cancel those expressions. It is 9x. The area of trapeze ABDF equals to 9x. So x equals to 2 times, actually it is 28, 2 times 14 is 28, times square root of 2 over 9. 9 over 9 is 1, so we found out that the area of the green shape equals to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, I'll repeat again. The area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green shape, and so in the first method we did a construction. We actually extended side CD and BE until they intersect with each other at point P, and we know that CD is one side of rectangle ABCD, therefore it is a straight line, and we extended the straight line CD by a straight line, therefore CP will be still a straight line. Okay, so CP is a straight line, and we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on this side of the straight line CP, then at point D, the sum of the angles must be equal to 180 degrees according to rule number 1. So this angle, that is angle X, plus 90 degrees must be equal to 180 degrees according to rule number 1. X plus 90 degrees must be equal to 180 degrees according to rule number 1. We subtract the 90 degrees from this equation, and we got that angle X equals to 90 degrees. We found out that angle X, this angle, is a right angle, it equals to 90 degrees. Then we know that AB is parallel to CD because the opposite sides of a rectangle are parallel to each other. So if AB is parallel to CD, AB will be also parallel to CP because CP is the extension of CD, so it is the same straight line as CD. So therefore AB will be also parallel to CP. Okay? So those two angles are defined as alternating angles, and they are located between the parallel lines AB and CP. And we have rule number 2 that alternating angles between parallel lines are equal to each other. So those two angles that are alternating angles that are located between the parallel lines AB and PC will be equal to each other. That is to say, angle AB equals to angle EDP according to rule number 2. But it is given us in the question that this angle is angle theta. So angle AB is angle theta according to what is given us in the question. So from this equality we will conclude that angle DPE also equals to theta. This angle is angle theta. Then we proved that those two right triangles can go into each other. Why they can go into each other? Because we know that AE equals to DE. AE equals to DE, it is given us in the question. We also know that angle BAE equals to angle DPE equals to 90 degrees. Those two angles, they are 90 degrees, they are equal to each other. And those two angles, they are equal to each other because they are vertex angles, and we have the rule that vertex angles are equal to each other. Okay, so we actually proved, and we also know that those two angles are also equal to each other. We proved that those two angles are equal to each other, that is to say, angle AB equals to angle EPD, and both angles are equal to theta according to rule number 2. We actually proved that triangle ABE is congruent to triangle EPD according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles in the side that included between those two angles in another triangle, then the two triangles congruent to each other according to angle side angle rule. Okay, and we proved that those two angles, we actually proved that those two angles and side AE that included in the green right triangle congruent to those two angles and side ED in triangle PED. Therefore, we proved that those two right triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that EB equals to EP. EB equals to EP, but we know that EB equals to 7 units, so EP will be also equal to 7 units. And we defined the quadrilateral EBFD as Y, and we defined the right triangle ABE as X. So the green area is X plus Y. So we have to find out the value of X plus Y in order to find out the green area. And because of the fact that those two right triangles can go into each other, they also have the same area. So if the area of the green triangle is X, then the area of this triangle will be also X. So the area of triangle BFP or BPF equals to X plus Y, exactly is the area of the green shape. That is also X plus Y. So we can actually find out the area of the triangle BPF that equals exactly to the area of the green shape ADFB. They have the same area, so we will find out the area of triangle BPF that also equals to X plus Y, exactly as the area of the green shape that equals to X plus Y. Okay, so the area of the green shape equals to X plus Y, and the area of triangle BPF also equals to X plus Y. So we'll find out the area of triangle BPF, and in this way we will find out the area of the green shape because they are equal to each other. Okay, so we know that triangle BPF is an isosceles triangle. Why? Because it has two angles that are equal to each other, they are both equal to theta. And we have rule number 3. According to rule number 3, the median to the base in an isosceles triangle is perpendicular to the base. What is the meaning of rule number 3? The meaning of rule number 3 is that if we have a right triangle, triangle ABC is a right triangle because it has two angles that are equal to each other, they are both equal to theta. And we have the median AO that bisects the base BC, that is to say BO equals to OC. Then according to rule number 3, the median to the base in a right triangle, like the right triangle ABC, it is also perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. We can implement rule number 3 in our drawing, because in our drawing we have the right the isosceles triangle BPF, and we have the median FE that bisects the base BP into two equal parts. BE equals to BP equals to 7 units. And according to rule number 3, because of the fact that triangle BPF is a right triangle, then the median to the base FE also is perpendicular to the base. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that this angle is a right angle, then triangle BEF is a right triangle. So we can use the Pythagoras theorem in order to find out the value of EF. And according to the Pythagoras theorem in the right triangle MBF, the square of the hypotenuse equals to the sum of the sides of the perpendiculars. That is to say, BF square equals to EB square plus EF square. BF is 9, so BF square is 81, plus BE is 7, so BE square is 49, plus EF square. Here, 81 minus 49 is 32, so 32 equals to EF square. So EF is equals to the square root of 32. 32 is 16 times 2, so in conclusion, EF equals to 4 times square root of 2. EF equals to 4 times square root of 2. Now it is very easy to find out the area of the isosceles triangle BPF. The area of any triangle equals to the base times the height over 2. And the base of the isosceles triangle BPF is BP. The height is EF. So it is BP, the base BP times the height EF over 2. BP equals to 14, EF equals to 4 times square root of 2. So we found out that the area of the green shape equals to 7 times 4 times square root of 2. That is to say, it equals to 28 times square root of 2 square units. So in terms of numbers, the area of the green shape equals to 39.6 square units. So that was the first method, and we actually found out the area of the green shape according to the second method also. According to the second method, we have rule number 2 that alternating angles between parallel lines are equal to each other. You know that AB is parallel to CD, according to the rule that the opposite sides of a rectangle are parallel to each other, and if AB is parallel to CD, AB will be also parallel to CF. So AB is parallel to CF, and those two angles are defined as alternating angles, and they are located between the parallel lines AB and CF, therefore they are equal to each other according to rule number 2. Okay? Okay, so this angle is theta plus theta, that is to say it equals to 2 theta, so this angle is also 2 theta. Okay, we found out that this angle is 2 theta. And we know that all the sides inside the rectangle, all the angles inside the rectangle are right angles, so this angle is right angle, this angle is right angle, this angle is a right angle. We focus on the right triangle, triangle ABE. We know that sinus theta is AE over EB, that is to say we defined AE as x, so sinus theta is x over 7. In the right triangle AEB, sinus theta is x over 7. And in the right triangle, triangle BFC, sinus 2 theta is 2x over 9, or sinus 2 theta is BC over 9, but we know that BC equals to 2x because the opposite sides of a rectangle are equal to each other, and AD is 2x, therefore BC will be also equal to 2x. In conclusion, we found out that sinus theta equals to 2x over 9. Sinus 2 theta equals to 2x over 9. And we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta. So we can substitute sinus 2 theta in equation number 2 by 2 sine theta cosine theta. We did it and we got that 2 sine theta cosine theta equals to 2x over 9 according to equation number 2. But we have already found out that here we have we have already found out that sine theta equals to x over 7 according to equation number 2. So we substituted sine theta by x over 7. And we got that 2 times x over 7 times cosine theta equals to 2x over 9. Here we have 2x on both sides of equation number 2, so 2x will get cancelled. And we got, after 2x will get cancelled, we got that that cosine theta over 7 equals to 1 over 9. We multiplied this equation number 2 by 7, and we got that cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9, and we already found out that sine theta equals to x over 7. So what is the meaning of cosine theta equals to 7 over 9? If we draw this function, we'll get a right triangle with one angle that equals to theta, one angle is a right angle. The hypotenuse is 9, and the side that is near angle theta will be equal to 7, and this is S is the missing variable. We can find out the value of S according to the Pythagoras theorem. Here, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say 7 squared plus s squared equals to s squared. We subtracted 7 squared from this equality, and we got that s squared equals to 9 squared minus 7 squared. 9 squared is 81, 7 squared is 49, so 81 minus 49 is 32. So we got that s squared equals to 32. We took the root of this equation, and we got that s equal to the square root of 32. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that s equals to 4 times square root of 2 units. And then, so if s equals to here square root of 2 units, we know that s equals to square root to 4 times square root of 2 units. So sine theta will be equal to 4 times square root of 2 units over 7. Here, actually, we found out that cosine theta equals to 7 over 9. And then here we have this, the right triangle. We know that sine theta equals to x over 7 and cosine theta equals to 7 over 9. We already found out that sine theta equals to x over 7. Okay, but we also found out that sine theta equals to 4 times square root of 2 over 9. So we substituted sine theta by 4 times square root of 2 over 9. So we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied this equation by 7, and we found out that x equals to 28 times square root of 2 over 9. So here x equals to 28 times square root of 2 over 9 here also. And if x equals to 28 times square root of 2 over 9, then 2x will be equal to 56 times square root of 2 over 9. Then we know that cosine theta equals to 7 over 9. And if we focus on this right triangle, triangle ABE, we'll get that cosine theta equals to AB over 7. Cosine here in this right triangle ABE, cosine theta equals to AB over 7. cosine theta equals to AB over 7, but we know that cosine theta equals to 7 over 9, so we substituted cosine theta by 7 over 9, and we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7, and we got that AB equals to 49 over 9. We found out that AB equals to 49 over 9, and then we focused on the right triangle BFC. On the right triangle BFC, we know that cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9. We multiplied this equation by 9, and we got that 9 times cosine 2 theta equals to FC. We have that trigonometric identity that cosine 2 theta equals to 2 cosine square theta minus 9. So we substituted cosine 2 theta by 2 cosine square theta minus 9. And we got this expression. And we know that cosine theta equals to 7 over 9. So we can substitute cosine theta by 7 over 9 in this equation number 2. So we did it, and we got that 9 times 2 times 7 over 9 square minus 1 equals to FC. So here 9 times 2 and 7 square, 7 over 9 square is 49 over 81. And minus 1 is minus 81 over 81. So in conclusion, we found out that 9 times 98 minus 81 over 81 equals to FC. 98 minus 81 is 17. So in conclusion, we found out that FC equals to 17 over 9. Here, FC equals to 17 over 9. And what is the value of DF? DF equals to DC minus FC. Okay? DF equals to DC minus FC. DC equals to 49 over 9. FC equals to 17 over 9. DC equals to 49 over 9. FC equals to 17 over 9. So DF equals to 49 over 9 minus 17 over 9. That is to say DF equals to 32 over 9. So we found out that DF equals to 32 over 9. And then we can easily find out the area of the green shape, that is the area of trapeze ABDF. It equals to AB plus DF times AD over 2. AB equals to 49 over 9, DF equals to 32 over 9, and AD equals to 56 times square root of 2 over 9. Okay, and 49 plus 32 is 81. Here is 81 over 81 is 1. So we left only with 56 times square root of 2. That is to say, the area of the green shape equals to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, so we finished with the second method, and then I presented to you how to find out the area of the green shape in the third method. In the third method, we actually drew perpendicular from point E to BF. So this angle is 90 degrees and this angle is 90 degrees. And we proved that those two right triangles can go into each other. Okay, so we actually proved the triangle ABE is congruent to triangle BEM. We proved the triangle ABE is congruent to triangle BEM. Why they congruent to each other? Because we have angle ABE equals to angle EBM equals to theta. Those two angles, they are both equal to theta, they are equal to each other. We have those two angles, they are right angles, they are equal to each other. And we also have those two angles, they are equal to each other according to third angle theorem. And we also have a common side EB is a common side, it belongs to both triangles. So we proved that those two triangles can go into each other according to angle side angle rule. Then, from the fact that those two triangles can go into each other, we conclude that AB equals to BM. Okay, AB equals to BM, and if we define AB as y, then BM will be also equal to y. And we can also conclude from the fact that those two triangles can go into each other that AE equals to EM. And if AE equals to x, then EM also equal to x. Okay, then we join together points E and F together by a straight line, and we prove that those two right triangles can go into each other. Why they can go into each other? Because we have EM equals to ED equals to x. Okay, and we also know that EF equals to EF, it is a common side that belongs to both triangles. And we also know that those two angles are right angles, therefore they are equal to each other. And we actually proved that those two right triangles can go into each other according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles can go end, then the triangles can go end to each other. And we actually proved that the hypotenuse and EF, the perpendicular ED in the right triangle EDF, can go end to the hypotenuse EF, and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. So we proved that triangle EDF can go into triangle EMF according to rule number 5. From the fact that those two triangles can go into each other, we will conclude that MF equals to DF. MF equals to DF, but we know that MF equals to 9 minus y, therefore DF will be also equal to 9 minus y. Okay, and what is the value? And then we know that FC, so this is FD equals to 9 minus y, and we know that DC equals to y. So what is the value of FC? FC equals to DC minus FC. Okay, again, FC equals to DC minus DF. FC equals to DC minus DF. DC equals to y and DF equals to 9 minus y. So FC is y minus 9 minus y, that is to say FC equals to 2y minus 9. So we found out that FC equals to 2y minus 9, and AD equals to BC, because the opposite sides of a rectangle are equal to each other. AD equals to 2x, so BC will be also equal to 2x. And then we focused on the right triangle, triangle BAE. On the right triangle, triangle BAE, according to the Pythagoras theorem, x squared plus y squared equals to 49. X squared plus y squared equals to 49. And in the right triangle, triangle FCB, according to the Pythagoras theorem, here FB squared is 81 equals to FC squared plus BC squared. Okay, 81 equals to FC squared, that is 2y minus 9 squared plus 4x squared. We open the brackets on this side of equation number 2, and we got that 81 equals to 4y squared plus 81 minus 36x plus 4xy. We have 81 on both sides of equation number 2, so 81 will get cancelled. And what is left here? We took a common factor of 4 for those two expressions, and we got that f 0 equals to 4 times x squared plus y squared minus 36y. We added 36y to this equation, equation number 2, and we got that 36y equals to 4 times 49. We divided this equation, equation number 2 by 4, and we got that 9y equals to 49. We divided this equation, equation number 2 by 9, and we got that y equals to 49 by 9. Okay? And then we put the value of y in equation number 1, that x squared plus y squared equals to 49. So x squared plus y is 49 9 over 9, so y squared is 49 over 9 squared. It equals to 49. So x squared, we subtracted 49 over 9 from this equation number 1, and we got that x squared equals to 49 minus 49 over 9 squared. We know that 49 is 7 squared, so in conclusion we found out that x squared equals to 7 squared minus 49 over 9 squared. And we use the algebraic identity that a squared minus b squared equals to a plus ba minus b. Here b squared is 0, a equals to 7 and b equals to 49 over 9. So in conclusion we found out that x squared equals to, according to the algebraic identity, that x squared equals to 7 plus 49 over 9, that is a plus b, and a minus b is 7 minus 49 over 9. Here we multiplied 7 by 9 and then we divided it by 9 in order to have a common factor with this expression, and we got that x squared equals to 63 plus 39 over 9 times 63 minus 49 over 9. 63 plus 39 is 112, and 63 minus 49 is 14. So, and here 113 is 8 times 14. So in conclusion we got that x squared equals to 8 times 14 times 14 over 9 times 9. We took a root out of this equation number 1, and we got that the area of the green shape of the trapeze ABDF equals to AB plus DF times AD over 2. We know that AB equals to y. DF equals to 9 minus y. So AB plus DF is y plus 9 minus y. Times AD is 2x over 2. Y minus y is 0, and 2 over 2 is 1. So in conclusion we got that the area of the green shape equals to 9x. And x equals to 28 times square root of 2 over 9. 9 over 9 is 1, so in conclusion we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers it equals to 39.6 square units according to method 3. Okay, thank you very much.